All right, let's begin. I think I'll start off by saying that from here on out, Wednesdays will be the day when I'll do the lesson for the week. I know there's a 5 or 6 in the live chat. The last week we did this, and I just think Wednesdays are the best days for me. So hopefully it works for you. Keep in mind you can watch this whenever. So those of you that turned in your problems from last week, thank you. I got them. I've received them. And for those that haven't done them yet, you still can. All right, I want to start today. We are continuing our look into quadratic equations and what we can learn from them, what they're for, and why we are doing quadratics. The last lesson, we looked at equations written in standard form and equations written in vertex form. And what we discussed were the differences between the two, what you could tell from a standard equation versus what you could tell from a vertex form equation. You know, they give you different bits of information, and from that we can kind of begin to sketch what the parabola looks like. We're going to continue working with quadratics for the next few weeks. And today's lesson is working on finding roots, or the x-intercepts. Because if you remember, last week we were able to determine whether the parabola opened upward or downward, where the y-intercept was, and equations written in vertex form where the vertex of the parabola is. All right, that's not enough to make a super accurate description of the parabola, but it does begin to tell you what it does look like and what it won't look like as well. So knowing where there are x-intercepts is also important. But first, we're going to go back and do a warm-up. And we were doing this right before we got closed out of the schools. But if you recall, we were multiplying binomial expressions. And in other words, we were using the FOIL method, for those of you that might remember that. So I'm going to put up the warm-up here, and then you can push pause and see if you can recall how to multiply those out, what FOIL stands for, and then what expression you get at the end when you do multiply. So either push pause on this and try and do those 2 warm-up questions the best you can. And I'm going to go ahead and continue working out what the answers to the warm-up are. So if you need a minute to work them out before you want to see the answer, then push pause, work them out, and then continue on. Okay. The FOIL method, if you remember, FOIL was an acronym that stood for first, outer, inner, last, and it tells you the order in which you should multiply your binomials. This, remember, is just an extended version of the distributive property, which says when you have a term outside of a set of parentheses, to simplify or to get rid of the parentheses, you multiply that term by every term that's on the inside of the parentheses. Well, here you have 2 items outside of a set of parentheses. So we would go first terms, x times x. Outer terms, or the terms furthest away from each other, x times a -5. Yes, you consider that a -5. Would be a -5x. Inner terms, I, 3 times x, are the 2 terms in the middle. And then L stands for the last terms. 3 times a -5 would be -15. Now, always you want to check to see if there are fractions you can simplify or reduce, or if there are any like terms you can combine. In this case, the x terms can be combined. -5x plus 3x would be a -2x. And there are no like terms with an x squared term or constant terms. So this would be the simplified answer to number 1. All right. Number 2, again, binomial terms. That means 2 terms together. So binomial or FOIL method, again, we'd multiply the first terms, f, so 5x times x would be 5x squared. 5 times 6 would be a positive 30x. X times 1 is just x. And the last terms would be 1 times 6, or 6. Everything's positive here, so everything's going to be positive in your answer. And again, we can combine our x terms to get our simplified results. Now, if I were to go through and let's say put a y in front of these two, then they go from quadratic expressions to quadratic equations. All right, in standard form, no less. Okay, when they're simplified, they are written in standard form. From this equation, you can tell from A would be 1 in this case, B would be -2, C would be -15. A tells you that this parabola opens upward. And this is just review from last week, just to recap. C in standard form tells you the y-intercept. So that's what we can deduce from an equation, this equation written in standard form. Okay, and again, that's refreshed from last week. What we can tell from the second equation, since A is positive, it's going to open upward. And A is 5, which is a number greater than 1, which is going to actually make it a lot more narrow. So it's going to be a very narrow parabola opening upward with an y-intercept at 0, 6. Okay? So again, recap from last week, equations in standard form, that's what we can tell just by looking at the equation. Now, the purpose of this week is to determine where the roots of an equation are. And roots are just another name for x-intercepts. Okay. Roots are another term for x-intercepts, and a quadratic equation or a parabola can have three different options for roots. You can have no roots. And that's if the parabola never touches the x-axis. All right, that's possible. Or if it opens downward, it still doesn't cross the x-axis. So no roots or 0 x-intercepts. A parabola can have one root. It can come down and touch the x-axis or intersect with the x-axis in one place. Or you can have two roots. Two roots would mean it comes down and then back up and ends up intersecting two places with the x-axis. All right, these are your three choices when looking at a parabola. You can have 0, 1, or 2 roots, right? But never any more than that, and obviously can't have less than 0. And for these, you can also do the opening downward versions of those parabolas as well. Okay. The most common and what we are going to focus on today would be two roots. So while these are possible, we're not going to focus on them today. I see there's two people in the chat. Hi, two people. All right. Equations written in standard form have two versions that we work with. When A is 1 and when A is not 1, essentially. It's very, let me back up. To find the roots, we need to factor this down into its simplest multiplying parts. Or in other words, what were the binomials that we multiplied together here to give us this statement? If we go back to our warm-up question, I'll put that right on top here. We started with binomials and we multiplied to get something that looked like a standard form equation. Okay, well, today we're going to do the reverse of that. We're going to take a standard form equation and then break it down and see what the two multiplying parts are. When A is 1, or there's just an x squared term there, the process goes a lot simpler. What you want to do, let me just rewrite this here. X squared plus, oops, should be a minus 2x. Apologies. Minus 15 equals 0. Okay, so first, why do we set it equal to 0? Well, if you recall, an x-intercept means you're going to go left or right some amount, but the y has to be 0. Okay, that's so that you stay on the x-axis. You can go left or right on the x-axis, but you shouldn't leave the x-axis in order to be an intercept. So the y-coordinate has to be 0. So if we substitute in for y, and that can go in the front or the back, it doesn't matter. Okay, then what we are essentially doing is solving for x by factoring. Now, when the a term is 1, all right, when we do our FOIL method, the o plus the I term, remember, those always combine together because we got two x terms that we combine together. Whatever you do to multiply your first terms together, that is this. All right, so factors of x squared would just be x and x. X times x is x squared. Okay, now the last term multiplied together has to be a negative 15. Well, there's some choices for that. It could be, in order to get a negative number, a negative product, one has to be positive, so 5, and the other would have to be negative, and negative 3. Or it could be negative 5 and positive 3. Okay? But before I put those in here, because there are a couple of choices, I want to check to see, well, do either of these choices, when added together, give me a negative 2? These products are going to give me a negative 15. That's how I got these numbers to begin with. They're factors of negative 15. But which of these factors also add up to give me a negative 2? Well, that would be these right here. Negative 5 plus 3 is a negative 2. So I would just write negative 5 and a plus 3 for my last terms. Okay? So what I have is here now. X minus 5 times x plus 3 equals 0. Well, to actually make this equal 0, what could I put in here that would set this whole equation to 0? Now remember, anytime you multiply by 0, 0 times any number is 0. All right, and that's what we want. We want to get this to equal 0. So what number could I put in for x here that would set this whole problem equal to 0? Well, if I put in a positive 5, 5 minus 5 is 0. And it doesn't matter what this ends up being because 5 plus 3 is 8. So it'd be 0 times 8, which is 0. So 5 is a solution. Okay, well, what about here? What's a number I could put in for x on this term, this part of the binomial, that would set this part of the problem equal to 0, because 0 times anything is 0? Well, that would be a negative 3. If I plug in negative 3 here, I get negative 3 times negative 8, and, excuse me, 0 times negative 8, and that, again, would set this whole problem equal to 0. So my x-intercepts are going to be at 5, 0, and negative 3, 0. And again, that's another piece of information you can now use to graph your parabola. Okay, so it's going to open upward. It's going to have a y-intercept at negative 15, x-intercepts at 5, 0, and negative 3, 0. And I should make that clear. This is not a point. It's 5, 0, and negative 3, 0. Those are your two x-intercepts. And if you recall, a parabola is symmetric. So the average of 5 and negative 3 is going to be your line of symmetry, and your vertex will be on that line at some point. But that's a side note. Okay, now I probably moved a little quick there. Let's do another example. Perhaps another equation. Let me see if I can come up with one. Okay, so quadratic equation here. A is 1, so that means when I go to solve this, remember my first terms, my outer plus my inner terms will combine to be a negative 9, and then my last term is a product that will give me 18. So when A is 1, the only factors of x squared are x and x. That's nice. When I multiply my last terms together, I should get a positive 18. Now, what are factors of positive 18? Well, there's 18 and 1, 9 and 2, 6 and 3. And that's it. Now, if these were all positive, then I should get a positive in the middle here, but I don't. I get a negative. All right, so that just means these are all going to end up being negative, because negative times a negative is a positive, but negative plus a negative is a negative. Okay, so then of these three choices, which ones add up to a negative 9? Well, those don't, these do. So I would go x minus 6 and x minus 3. You could have them switched. It doesn't matter. So then, what are my actual answers for x that make this equation equal to 0? In other words, what could I put in for x here or here that would turn this to 0, and 0 times anything would be 0? Well, if I put a positive 6 in there or a positive 3 in here, then that's where my x-intercepts will be, at 6, 0, and at 3, 0. All right, and just to sketch this on a graph. 1, 2, 3, 4, 5, 6. 1, 2, 3. My x-intercepts are here. My y-intercept is somewhere at 18, wherever that is on your graph. So my vertex would be, or my line of symmetry would be at 4.5. Anyway, that's all we can tell from this equation in standard form at this time. All right, but you don't have to graph. You won't have to do any graphing. I'm just throwing that in there for as a reason why this helps us. Okay, it helps us in our graphing. All right, so what do we do then if our example sorry about that. What do we do if our example doesn't have 1 for A? Okay, hope you can see that okay. When A isn't 1, what do we do? Well, it's a little trickier. First of all, everything's positive in here, so that means in our factored form, everything should be positive. Okay, that's good. That's helpful. Remember that our first terms have to multiply to give 2x squared. Our O plus our I terms give us 8x, and our last terms give us 8. So right here, 2x squared, if it was just x squared, it would be x and x, but it's 2x squared. Well, 2 is a prime number, so that's nice. So my factored terms have to be 2x and x. Okay. This changes a little bit for O and I here, and I'll get there in just a second. But my last terms, I know that my last terms have to multiply together to give me 8, a positive 8. And I know that everything's positive in here. So that could be 8 and 1, 4 and 2. Those are my only choices. However, neither of these add up to an 8, right? 8 plus 1 is 9. 4 plus, oh wait, no, 4 plus 2 is 6, sorry. And so the answer of which one of these and which order isn't immediately evident, because I'm going to have to multiply one of these terms by 2 to get to 8. Okay, so 2 times one of these numbers plus the other should give me 8. Well, if I go 2 times 8, that's 16 plus 1. That's not going to work. If I go 2 times 1, that's 2. 2 plus 8 is 10. That's not going to work either. All right. 2 times 4 is 8. 8 plus 2 is 10. That's not going to work. 2 times 2 is 4. 4 plus 4 is 8. Okay, so I'm going to use these two pairs, and I'm going to make sure that the 2 is going to go here and the 4 is going to go there. All right, because, again, foiling this out, 2x times x is 2x squared. 2x times 2 is 4x. 4 times x is 4x. That's where we get our 8x. And then 4 times 2 is 8. Okay, so now we've broken this down into its factored form correctly, but it takes a little bit longer when a is a number and not 1, like in the previous example where a was 1. Okay, so again, once we have this broken down, what can I put in for x here and here that will set this equal to 0? Well, what plus 2 is 0? Well, -2. That is one of the x-intercepts at -2. However, here I got 2x plus 4. To figure out what x could be here that would set this equal to 0, I actually have to solve this little two-step equation. So I subtract 4 from both sides to get 2x is equal to -4, divide by 2, and x is a -2. So when you have x-intercepts that are the same number, that just means you only have one intercept. This parabola is going to be a little bit narrower and open upward. It's going to have a y-intercept at 8. It's going to have an x-intercept at -2. So again, skinny and one intercept. Excellent. So that's a case where you would only get one intercept. But like I said, for the most part, we're focusing on equations that will have two intercepts today. But you can see that one intercept is possible. Okay, just because we're getting close to that half-hour mark. Nope, Maddie, this is for algebra, not 7th grade. But thanks for checking in. Here's what I want to do. I'm going to give you 6 problems to do where you're going to factor to find the roots. You're going to break down the standard form equation to give me where the y-intercepts are. So you'll factor these all down, and you'll note that there are 2 problems where A is not 1. The rest of these A's are 1. Okay, and those, when A is 1, they factor a little easier. Okay, so let me know if you have any questions. You can just push pause for these 6 questions at the end of this video to see what exactly you need to do. There's not a ton of questions, but I do expect there to be some questions that from your end. So I plan on posting the answers to the 6 questions on Friday so that you can correct your answers, correct your work. And remember, it is okay to reach out to each other as well. So reach out to your other classmates, and maybe you guys can work out your questions together. But again, I'm always available, especially from 10 to noon every day. All right. If you need to see this a little bit longer, push pause. Otherwise, I'm going to bounce out of here and hope to hear from you soon.